In this video, we're going to talk about a bisector of a segment. So a segment bisector is going to split a segment into two congruent parts. So anytime we see a segment bisector, so segment bisector, that's going to imply two congruent segments because you're splitting a segment into two equal parts. So that's kind of like your shortcut for that. So when we talk about segment bisectors, they can be a mix of different things. So you could have a line that's a bisector, you could have a ray, you could also have another segment. But in the end goal, you can only bisect a segment, so it has to be a segment, and it's getting cut into two equal parts. So segment AB in all of these pictures is getting split into two equal parts. If we talk about a perpendicular bisector, the difference is it's going to be a segment, a line, or a ray that's perpendicular to the segment and bisecting. So it has to do two things. So if you have a perpendicular bisector, this is a symbol for perpendicular, that implies perpendicular lines, meaning the lines are perpendicular, and two congruent segments. So you get two things out of that. So if we look at this example down here, it says that AB and CD bisect each other at point E. So that means you're going to start off with two segments, however you want to draw them, and they're bisecting each other. So I'm going to label the points AB and then CD. And they're bisecting each other at point E, so that means this will be point E. If they're bisecting each other, it means that AB is cutting CD into two equal parts, so those two parts are equal, and CD is cutting AB into two equal parts, so those two parts are equal. So now if I label what they give me, so AE is 5x plus 56, BE is negative 3x plus 194, CE is 4y minus 332, and DE is 3y plus 184. Now, whenever we have two variables, it really means you're going to have to use two equations. So if I look at the relationship between these, since I have segment bisectors, that means we have two congruent parts. So segment bisector implies two congruent segments, which is what I just labeled. I just labeled the two congruent parts. Two pairs of congruent parts, so those two sets and those two sets. So if I want to solve for x and y, well, I know that these two pieces are equal, and then I know those two pieces are equal. So it's going to be two separate equations. So the first one, to solve for x, I just set these equal. And then I solve. So get x by itself, so bring the 3x over, subtract 56 from both sides. So I get 2x equals, 8x, not subtract them. Add those up, 5 plus 3, and then equals 138. Divide by 8, and you get 17.25. On the calculator, make sure you hit Control-Enter if you're trying to get a decimal, because otherwise it'll make it a fraction. And then for the y, I set the two y pieces equal, the two parts, since it was a segment bisector. And when I solve, so subtract 3y from both sides, add the 332. So those cancel, those cancel. So I end up with y equals, add those up, 516. So if you have a bisector, then the two parts are equal, so then you would just set your expressions equal and solve for those variables.